Hello everyone, welcome back to Under the Apple Tree, and today we're going to be solving some differential equations, specifically exact differential equations. It's a very unique type of differential equations, a very specific solving method, and so I think it's definitely worthy of a video to go and solve them. So let's just go ahead and jump right in. So usually when you're given a question, like on an exam for example, for an exact differential equation, it'll be in this format where it's going to be some polynomial times dx plus some other polynomial times dy. And basically we're just gonna call this one m. Just gonna call this one n. Basically, our polynomial that's multiplied by dx, we're gonna take the partial derivative of that with respect to y, and then we're gonna take the partial derivative of our dy over here with respect to x. And if they're equal to each other, then it's exact. And that probably sounds kind of complicated and nasty, and it does sound pretty bad and confusing, but once you work it out, it's actually not too bad. So let me just write down, this is how you know if it's exact or not. Partial of n over x. Okay. This is assuming m is multiplied by dx. This is assuming n is multiplied by dy. So let's take the partial derivative of dm to dy. Okay. And that's going to be equal to, so we assume x is a constant here. Hopefully you have some experience with partial derivatives. And the derivative of y is just going to be 3x squared. And the 5 term is going to go away. Now we're going to take the partial of n with respect to x. And this is going to be 3x squared. Simple power rule here. The 4 goes away. 3x squared. And we notice these are the same. That means we are exact. Which means we can go about solving it now. So we haven't even started solving it. We just verified, yes, this is exact. Okay, and so now at this point, you have to take an integral. And you can use either m or n. And it doesn't matter. It works for both, but you just should pick the one that looks easier to integrate. So, and I'm gonna choose m over here. And so I'm gonna do a little footnote f sub x. So we know that I'm using dx, basically. Now we're going to put our integral in, and m. The integral of m, 3x squared y plus 5. And we're going to throw in that dx also. So we're integrating with respect to dx. Excuse me. Now let's go ahead and integrate this. And what we're going to get is x cubed. Well, basically, yeah, you integrate that 3x squared. You add one exponent, so you get x to the third, and then you divide by a third until the 3 goes away. So you have x to the third times y plus 5x and then plus a constant. But since this is a multivariable integration, we don't know if it's a constant or some function of y. It could be, plus 2, but it could also be plus y squared. We just don't know. So we're going to put in plus f of y. So some function of y is going to be in here. And this is all still function of x. Now what we're going to do is we're going to take the partial derivative with respect to y. So let's just draw this in here. At this point now we're going to take the derivative with respect to y. And once we do that, we'll get x cubed. And then everything else will go, this will go away, this becomes 0. And then the derivative of f of y will be f prime of y. Okay, and so now we have a function of y. Alright, and so, well, we know that fy is equal to n. Let's just do a little side note here. Fy is equal to n. And so what that means is that we can plug them into each other, or we can set them equal to each other. We can set n equal to f of y. So what we'll get is x cubed minus 4 is equal to x cubed plus f sub y, or f prime y, sorry. And now we solve for f prime of y. Well, x cubes cancel, and f prime of y is just going to equal negative 4. Okay, well, what does this mean? What is this? How is this even good? Well, we have an f prime. We have what f prime equals, and up here we have the differential equation, our solved differential equation. I should add, but we still don't know the constant. We still don't know f of y. We have f prime of y, but we need to get f of y. So we can just integrate this to get f of y. We'll integrate this with respect to dy, because it is a function of y after all. And f of y is equal to negative 4y. And then you can just plug that back in up here. So that means your function is x cubed y plus 5x minus 4y. That's the answer for this exact differential equation. Okay, and that should wrap up this video pretty much. Hopefully you have a better understanding of exact differential equations. It's very procedural once you get it down. And I do want to add, I chose to do dx here, but you don't have to. You could use n, you could use dy, but then you would take the partial derivative with respect to x. And so you'll get the same answer. It'll just, the algebra will work out differently. Okay guys, that's going to wrap up this video. I hope you learned a lot. Good luck on all your exams. See you next time.